Hello everyone, this is Swati Shastri and welcome to the lecture series on computer networks and security. So this is our third lecture. Before going to the today's lecture, let us have a recap of what we have learned in the previous class. So in the previous class, we have learned about certain principles of network applications. We have continued with that. So the principles of network applications that we have seen in the previous class is regarding the transport services that are provided by the internet. So internet is having a large set of transport service, and that is called as TCP service as well as UDP service. So we have learned that TCP is a connection oriented protocol and UDP is a connection less protocol. So apart from transport services, we have also learned about application layer protocols. There are two kinds of application layer protocols. One is public domain protocols, and one more that we have learned is proprietary domain protocols. So with this basics, we'll let us move on to the today's topic and what are the contents that we are going to cover today. Let us see that. So today we are going to cover two things. That is, we are going to start about something called as HTTP. We will see the overview of it and what kind of connections are present to HTTP is what we are going to see. So let's start. So this is a part of the syllabus or the textbook that we are going to learn. You already know the textbook, that is Jim Croce and Keith Ross. Computer networks is what we are going to study. It is the second chapter, second part that we have chosen the topic right now. So when you consider web and what is the HTTP, what is the relationship between web and HTTP? So these are the things that are the basic things that we are going to learn. So what does the word web mean? Web, as the word says, web is nothing but the things that you use. HTTP is a supportive thing for web. Okay, when you say web is more normal browsing. A common man, what he uses for browsing is considered as web. So to browse, a common man to browse, you require HTTP. Okay, so this HTTP is a protocol. Okay, HTTP is a protocol, and that protocol is running on application layer or running in application layer to support the web. Okay, to support browsing, HTTP is being used in the application layer. So whenever you consider this kind of concept, we always believe that our web is running on something called as on-demand services. We are always running on on-demand services. For example, if you consider Google, you want to fetch some information from the Google. It is like you being a client will be requesting Google server to send the information, not just information, even the Google page, correct? So if you request only, then he is going to give you the response. Because you have a relationship of one is requesting and one more is responding, we believe that whatever services we are undergoing, we call them as on demand. On the demand, you're going to give it. So before we start with a deep discussion about HTTP, how it runs, what it is, let us first understand some handful of jargon words which are always required. So first thing is, what we need to learn is what is a web page. Okay, whatever we browse, we get it in form of pages, and we call that as web page. Okay, you click on Google or you click on Gmail or any other sites, whatever thing appears on your browser, that is called as a web page. Okay, so web page is always going to consist of full of objects. It is having always objects. So what is the meaning of this objects? Object is an HTML file, or it can be an image, or it can be an applet or an audio file. Consider that. For example, to understand that better, you just consider a Google page where you have typed like flowers. What you get is you get a complete page first. The thing that is getting displayed is called as that is called as a page, that is an HTML file always. So whatever page is being designed, it is always designed using an HTML file. So that will come first, and the contents inside that, you will be having small images, or you may be having an audios in that. So they are all a kind of files that are placed over there. So those files are also called as objects. Okay, so web page is a thing that consists these objects, and objects are nothing but HTML files, JPEGs, all the files, all kinds of different kinds of files are called as object. Okay, so web page always consists of a basic HTML file which includes several referenced objects. That's what I told you, like when you open Google, it opens an HTML file actually. In that HTML file, you have small files, that is your image files that is being placed, correct? So it is having a basic HTML file, and you are having certain referenced objects to that. So for example, if you want to see, let me show you an example over here. If you consider Google, okay, I have a page. If I want to search for some wallpapers, okay, I select wallpapers. In this, I'm going to select images, fine. So what is this? So I get so many things, right? So this particular part or area is called as HTML file that comes in. This is a basic HTML file, and you have so many small things that are files itself. If you click on that, it is getting opened. So they're called as files itself. So this particular file is considered an object. This is a JPEG object, or maybe PNG object, any kind of an object. So these are what are called as objects. Okay. These are what are called as objects. So every object is addressed by its own URL. Every object is addressed by its own URL. So if you want to see that in an example, so when I have clicked on this object, you got something over here. So this is called as an URL. We call that as an URL. That is a location where this particular file is being stored on net or on the server. So that's called as URL. Okay. So every object that you are trying to access is addressable, and it is always having URL. Now URL is made up of two things. So you can see the example over here. So when you see the example over here, you can find that some www.someschool.edu/some-department/pic.gif that you have. The first part that you got, like www.google.com or www.someschool.com, or our college website www.klsbdit.edu.in. So these complete names are called as host name, or you may also call it as domain name. So domain name is very specific, but this is a better word is host name. So this is called as host name completely .edu.in. So until and unless the first slash occurs, that is called as host name. That is a main server of your organization. From there you have divisions. Okay, so this is called as host name, and the other part of the URL where it leads to the specific object is called as path name. Okay, so what we learned is we have a web page. Web page is full of objects. Objects are all kinds of files that is present on that page. Whenever you have a web page is going to learn a basic HTML file, and those HTML file is full of objects. And every object is having its own URL so that it can be addressed. And this URL is divided into two parts. The first part of the URL, until and unless the first slash occurs, is called as host name. And second part of the URL, we call it as path name. Okay. So with this basics, let us start learning what is the meaning of HTTP. Okay, so HTTP stands for Hypertext Transfer Protocol. So this is a protocol which is running in the application layer. Okay, so why do we need this HTTP? HTTP is especially or basically meant for client server model. So basic use of it is client server model. Consider that PC is running an Explorer, or PCs or any other PC which is running a Mac or a Navigator, like Explorer with respect to Windows or Navigator with respect to Mac OS. Okay, so if this particular PC wants to request, that is your Explorer PC wants to request the server something, some file, so it can send an HTTP request and get that file. The same file, if it is required by the Mac running OS, he will also be sending the HTTP request and will be getting his response. It means that HTTP is going to run on any kind of an OS without any problem. So you have on the servers or on the client side your browser that requests the service, displays the web object that is going to run your HTTP protocol, and server sends that particular object on that request on the HTTP protocol itself. So the servers who are going to run this HTTP protocol, we call them as web servers. We call them as web servers. If you consider your Google is the best example for your HTTP server. Okay, so whenever you consider HTTP is always working on a port number called as 80 on the server side. It is always working on a port number 80 on the server side. Okay, so let us have a bit detailed study regarding HTTP. When you consider HTTP, this protocol is always making use of something called as TCP protocol on the transport layer. Okay, this is always true. If you're using HTTP protocol in the application layer, it is going to make use of TCP protocol in the transport layer. Okay, so client is going to initiate the TCP connection to the server. That server is always going to have port number 80. Okay, you have a client, you have a server. Server is always called as a web server because we are using HTTP server. All HTTP servers are always called as web servers, and they are always running on port number 80. They always have word as port number 80 only. Okay, so on that port number 80, your server is start, and the client is going to start the connection with the server using TCP, which creates a socket and makes a connection on the port number 80 itself. So client's port number is not 80. Client's port number is definitely not 80. Client's port number is quite high, which is not fixed. Rather, your server's port number is fixed to 80 because it's going to use HTTP. Okay, so whenever client requests for a connection, server accepts the TCP connection from the client, and HTTP messages are exchanged between the browser and the web server. So browser is actually running on HTTP client. What we learned is whatever client you have, for example, when you're operating on net, you're always a client, correct? So if you are typing google.com, you as a client initiated the connection to the google.com. You are the one who have sent the request to google.com, whereas Google is a huge server, correct? How do you send this request? Via a browser. Browser can be anything. It can be your Mozilla Firefox, Google Chrome, Internet Explorer, Opera, any of them. Any of your browser, you go to that browser and you start your google.com, correct? You type google.com. So server is an HTTP client. Whom did you send a request to? You have sent a request to a Google server on HTTP. That's why Google server is always a web server, which is an HTTP server. So after the messages are being exchanged between a client and a server, we close that TCP connection. We close that TCP connection. Okay, the main property of HTTP is that it behaves stateless. Now, what is the meaning of state? So whenever you consider state, the meaning of state is the past history. The meaning of state is past history. So whether the server is going to store the complete history of client. For example, when I am using a computer over here, I go to google.com, I click on something, I type something and I search for that. Okay, so after that I close that google.com. Whether that after closing that, whether that complete history is available on the server side, whether server knows that I had visited before and I was looking for this item. If it is a Google server, definitely no, because server being stateless will not store any client's information. Okay, server never stores any client's information. Client is the one which is going to store all the information. That's why we have history in our own browser. So server is not going to maintain the history, rather client maintains his own history. So if I have a client server crash and the views of state may be inconsistent and I may have to reconcile it, I may have to recheck it or rebuild it. So whatever servers you have, server never maintains any state. It doesn't know what client was browsing at this particular time. So HTTP is a thing which is stateless. Server does not maintain any information about the client, what it had requested, what it was doing last time. So if it is this time, like for example, my page was open, right? Like Google page was open wherein I have searched some wallpapers. So right now Google is remembering me. That is not a problem. But once I close it later, Google will not remember me. Rather, my client will remember what I had searched for. Okay. So whenever you consider such kind of HTTP, you should be bothered about connection. Why should I bother about an HTTP connection? When I consider HTTP is a TCP kind of a thing, right? It makes use of TCP protocol. So TCP is always interested in connection oriented. Correct? TCP is a connection oriented protocol. That is, before it sends the data, it has to set up the connection. Correct? So because TCP is connection oriented protocol and HTTP is resting over TCP, I should bother how the HTTP connections go on. Whenever you consider HTTP may have two kinds of connections. One being non-persistent connection, one more being persistent connection. Okay, HTTP connections can be of two kinds. One non-persistent connection, one more persistent connection. So what is the meaning of non-persistent connection? When HTTP makes use of non-persistent connection, it is something like once the object is traversed from the server to the client, it reaches the client, that particular connection is closed. That particular connection is closed. What is the meaning of that? Consider that I request the same page of Google. I requested certain photos of wallpapers to Google server, right? So when I click on that particular wallpapers, so I got lots of images. Consider that I have 10 images. Okay, so client has requested 10 images from the server. Now every image is considered as one object, correct? So when one object travels right from server to the client, after that travel, server will cut off the connection. So for the next object to come in, client has to request once again for the connection, make that connection and send that particular or get that particular object. So in non-persistent connections, what is going to happen? For every object, you create a new connection. On that new connection, you get that particular object and you will close that connection. But that is not happening in your persistent connections. So if I have multiple objects traversing right from server to the client, until and unless all the objects are not traversed from server to the client, it is not going to cut the connection until then. Okay, so that is what is going to happen in non-persistent and persistent connections. To understand this better, let us go through the further parts. When you consider a non-persistent connections, suppose that you have, for example, let us consider that you have a URL, that is www.someschool.edu/department/home.index. So in this you want this particular file to open in your browser. Okay, if you type this, your file is going to open, correct? Because it is a URL. Now consider that this home.index file is going to have some 10 images to be displayed in that. So if I say 10 images, it means that I have 10 objects that should be traversing right from the server to the client, or it should start from the server and it should reach the client, correct? So this becomes my requirement, correct? So what happens? Let's see the process. On the first part of the process, HTTP client will initiate TCP connection to HTTP server at some www.someschool.edu on port number 80. Now what is my first responsibility? If I want to fetch this, first I have to enter the URL, correct? I open my browser. Being a client, I open my browser. In that browser, I will type this particular URL. When I type this particular URL, what is happening? Your browser is acting like a HTTP client, and it initiates this TCP connection. It starts the TCP connection. To whom? To this particular server. It will start the TCP connection to the web HTTP server. Where is this HTTP server? HTTP server is present at www.someschool.edu. Correct? So because it is HTTP server, it has to definitely run on port number 80. So my client starts to search www.someschool.edu on the port number 80. So once it finds that, it sends it to that particular server. It sends a request saying that I want to get connected to you. So when this particular request reaches the server, what happens on the server side? HTTP server at the host www.someschool.edu, it is waiting for TCP connection at port number 80, and it will accept the connection, notifying the client. That is, when I click this particular server that is present, that is usually server is always kept on, correct? We have seen that in our first lecture. We have seen that in our first lecture, saying that our server must always be kept on. So because server is always on, it is waiting for the connection, saying that the connection, someone will request for the connection. When it is waiting for that connection, at the same time your client will send the request saying that I want to get connected to you. So now what server will do? The server will accept this connection and notify the client saying that he has accepted the connection. Once he notifies that he has accepted the connection and client gets to know, he will go for the second step. What is the second step? HTTP client sends request message into TCP connection socket. He sends a request message into TCP connection socket. Message indicates that client wants object, that is some department / home.index. Now what client is going to do? Client is going to send a request message. What is the request message? The request message is a URL. What is the URL? www.someschool.edu/somedepartment/home.index. Now till edu he has done. What is left? Only the path name is left. So he will send that path name to the server. What will server do? Server, that is HTTP server, it will first receive this request message. It will get that request message and it will start formulating the response message. It has to respond back. If someone has requested you, you will respond to that request, right? So it will start responding. What should it happen? What should it do in respond? It contains a requested object. That is, it has requested home.index, right? So what will server do? It will send that particular object and sends it to that particular socket. So once it sends to the particular, once it sends to the client, what should server do? HTTP server will first close the connection. It has sent the file. What client had requested for home.index, correct? So server sent home.index, but server is least bothered that home.index needs 10 more objects to run it or to show on, correct? It is least bothered about that. So what server did was it sent that home.index and it closed the connection. It did not wait whether client has received or not, or whether client is in need of some other help or anything. It did not wait for that. It just closed off the connection, correct? But when this thing reaches your client, so what is client doing? HTTP client receives this response message containing this HTML file. It receives this message and displays that, but after parsing this, when it checks that, it finds that it has got some 10 referenced JPG objects, that is JPEG objects. When it requires this JPEG objects, what it will do? It will start requesting the server with these 10 objects. If it wants to request, can it request all the 10 objects in the one go? Not possible. It can request only one object in one message. So what it will do, for 10 objects, it is going to repeat step number 1 to 5, the previous slide till this 5, it is going to repeat for every object. So every object the server sends, it will cut the connection. Again, client will create the connection, it will request one object, server will send that object, it will cut the connection, so on. So it will go on repeating. So this is how your non-persistent HTTP connection work. So this persistent, rather if I consider persistent instead of non-persistent, it is completely opposite of it. It is going to retain the connection until and unless all the objects from the server is going to reach the client. Okay. So when I consider this non-persistent connection, what is the effect of this non-persistent connection, HTTP connection, on the time, correct? So whatever times we have, we measure this time in terms of RTT. So RTT stands for round trip time. RTT stands for round trip time. What is the meaning of round trip time? It is a time for a small packet to travel from client to server and back, that is from server to client. So one packet is going from client to server and server is going to respond back. So this one full cycle is called as RTT. Okay, so when I consider a non-persistent HTTP connection, what or how much amount of RTTs or how much amount of time is required? So it can be divided into two sections. If you see the diagram, you can see here. So what is the process? First, you request a connection. As a response, server will send you the response saying that you can request a file. You can have the data transfer. It will accept that particular connection. Then client has to request for a specific file. Then server will send the specific file. Now you can see here, client is first requesting a connection and server sends an acknowledgement saying that it can accept the connection. So this is one RTT. One packet has moved from client to server and from server to the client. Okay, after this, what do? You set that particular object, you ask for that particular object. So one request and then server is responding with that object, that request, and this particular thing is a big file, correct? It is not a small request or a response, it is a big file. So it has got some transmission time also. So totally the response time, if I am trying to use non-persistent HTTP, my total response time will be twice the RTT, 2 times the RTT plus the transmit time, and this much of time is required to transport all or single object. Like in a previous example, we saw that we first were in need of home.index. After home.index was in need of 10 more objects. So 11 objects I was requesting. For every object I require this much amount of time. Correct? So, but what is the problem with this? The problem is that server is going to cut the connection every now and then. That is, after transfer of every object, your server will cut the connection and you have to generate a new connection. So that is a problem regarding your non-persistent connections. So what about persistent connections? When you consider persistent connections, same thing occurs. First it requests for the connection, server has to respond saying that connection is okay, and then it has to request an object and it has to send the object. So persistent is also the same way. The only difference is that this will not be repeating for the every object. Until and unless all the objects are traversed from the client to the server, and client will not initiate the close connection from its side, until then all your connections are kept open from the server side. Okay, so let's make a brief differentiation between non-persistent and persistent connections. When you consider non-persistent connections, it requires two RTTs for every object and OS overhead for each TCP connection. The browsers often open parallel TCP connections to fetch the referenced objects. But if you consider persistent, server leaves the connection open after sending even the response. Correct? After sending the response. Rather, subsequent HTTP messages between the same client and server, that is, it has been sent over the open connection. Whatever subsequent HTTP messages are getting exchanged, it is exchanged on the same connection, which is kept open. Which is kept open, correct? Thirdly, client sends request as soon as it encounters a referenced object. Whenever you have a referenced object, it will encounter the request. It has encountered the object, it will send the request and it will take it. As little as only one RTT for all the reference objects is required. So this is a brief differentiation between persistent and non-persistent connections. So let us sum up what we have learned today. So we have learned about a transport service. We have learned regarding application layer protocols and HTTP connections. We have learned about we have also learned about all the persistent connections. We have learned about non-persistent connections. We have seen what is a web page. So thank you. We'll stop here. We'll continue in the next class. Thank you.